Welcome to the video lecture for section 2.2. This is for MSc 1105, and my name is Hardy Young. And in this section, we're going to be graphing equations in two variables. We're going to find intercepts and also symmetry. And so the first thing we do is graph equations by plotting points. So here we have y is equal to 2x plus 5. We're going to graph this by creating a table of points. And so the graph consists of all the points x, y that satisfy the equation. To locate some of these points and get an idea of the pattern of the graph, what we do is we assign some numbers to x, and then we find the corresponding values for y. So by plotting these points and then connecting them, we obtain the graph of the equation, which is a line, and this is shown in the next slide, which is this one. So here we just arbitrarily chose 0, 1, negative 5, 10. You could have picked negative 2, negative 1, 0, 1, and 2. That would have been okay. And then you just connect them just by connecting the points and creating the graph. Here we have y is equal to x squared, so we're going to do the same thing. We're going to create a table of values. The first example was a linear function, or linear equation. You don't need that many points for this one. This is a parabola, and so it's a good idea to get more points, especially if you're not using technology to graph it. So in this example, they went from negative 4 to 4, and so they substituted each of those values into the function, to the equation, and they got the corresponding output, and we got the x and y points. So you can see here that they were able to create a pretty good graph using the points. Of course, if you're doing this by hand, it's not going to look like this one, but you should be close. And then the next thing we're going to do is find intercepts from a graph. So the x-intercept for a graph is when the graph of the line crosses the x-axis, and the y-intercept is when the graph crosses the y-axis. So you can see here that it crosses or touches the x-axis at 3 different points, and the same thing with the y-axis. So here's some examples, and so I'm going to go from left to right. And so the first point, negative 3, 0, is an x-intercept. And then we got 0, 3. That's a y-intercept. Then we also have 0, negative 4 thirds, so another y-intercept, and also 0, negative 3.5. And then we got 3 half 0 and 4.50. So if you have the graph of an equation, you can actually find the x-intercepts. Just find where either A touches or B crosses either the x or the y axes. Next thing is going to find intercepts from an equation. So to find the x-intercepts, what you do is you let y equal to 0 and you solve for x. To find the y-intercepts, you let x equal 0 and you solve for y. And so here we're going to find the x-intercepts and the y-intercepts of the graph of y is equal to x squared minus 4. And then we're going to go ahead and graph the equation by plotting points. So for the first one, to find the x-intercept, we're going to let y is equal to 0. So you can see that the original was y is equal to x squared minus 4. So now it becomes x squared minus 4 is equal to 0. You factor out the x squared minus 4, and you get plus or minus 2. So the equation has 2 solutions. So the x-intercepts are negative 2 and positive 2. To find the y-intercept, we're going to let x equal 0 in the equation. We're going to solve for y. So we get y is equal to 0 squared minus 4, which is negative 4. So the y-intercept is negative 4. Since x squared is greater than 0 for all x, we deduce from the equation y is equal to x squared minus 4 that y is greater than or equal to negative 4 for all x. So this information, the intercepts and the points from table 2, are going to enable us to graph the equation y is equal to x squared minus 4. And this is what it looks like. So one of the first things that you would do here if you were doing this by hand is to plot the negative 2, 0, the 2, 0, and then the 0, negative 4, sorry. And then you want to pick points on either side of the vertex. And so that in this case would be negative 1, negative 3, and 1, negative 3. And of course, just to kind of reassure yourself, you can do plus or minus 3 and then 5. So the next thing we're going to do is test an equation for symmetry with respect to the x-axis, the y-axis, and the origin. And so a graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, the point x negative y is also on the graph. So this is symmetry with respect to the x-axis, so the x-axis acts as a mirror, if you will. So points symmetric with respect to the x-axis. So if a graph is symmetric with respect to the x-axis and the point 3,2 is on the graph, then the point 3, -2 would also be on the graph. Now, the graph is said to be symmetric with respect to the y-axis, and for every point xy on the graph, -xy is also on the graph. So again, here the y-axis acts as the mirror. Points symmetric with respect to the y-axis. If a graph is symmetric with respect to the y-axis and the point 5,8 is on the graph, then the point -5,8 will also be on the graph. And then the next one is symmetric with respect to the origin. If for every point xy on the graph, the point -x, -y is also on the graph. So again, here the origin is the one that acts as a mirror. And point symmetric with respect to the origin, if the point 4,2 is on the graph, then the point -4, -2 would also be on the graph. So how do you test for symmetry? So there's 3 steps. For the x-axis, you replace y by -y in the equation and you simplify. If an equivalent equation results, then the graph of the equation is symmetric with respect to the x-axis. The y-axis, you replace x with -x in the equation and you simplify. If an equivalent equation is a result, then the graph of the equation is symmetric with respect to the y-axis. And in the origin, you replace x by -x and y by -y in the equation and you simplify. If an equivalent equation results, then the graph of the equation is symmetric with respect to the origin. So remember, x-axis replace y with -y, y-axis replace x with -x, and the origin you replace x and y by -x and -y. So here we're testing for this equation for symmetry. So the first thing here is we're going to replace y with -y. Now, since -y is equal to 4x squared over x squared plus 1 is not equivalent to the original, then the graph is not symmetric with respect to the y-axis. Now, for the y-axis, to test for symmetry, we replace x with -x, and then y is equal to 4 times -x squared over -x squared plus 1, which results in an equation that is equivalent to the original. So then the graph of the equation is in fact symmetric with respect to the y-axis. The y-axis will act as a mirror. And then to test for symmetry with respect to the origin, we're going to replace x by -x and y by -y. And then here, since the result is not equivalent to the original equation, the graph of the equation is not symmetric with respect to the origin. And this is what this one looks like. And you can see that it is in fact the y-axis. So know how to graph key equations. So graphing the equation y is equal to -x to the third by finding intercepts, checking for symmetry, and plotting points. So graph the equation y is equal to -x to the third by plotting points. You're going to find any intercepts and you're going to check for symmetry first. So first find the intercepts. When x is 0, then y is 0. And when y is 0, x is 0. So the origin is the only intercept for this particular equation. And then we're going to replace y by -y, because -y is equal to -x to the third is not equivalent to the original, so it's not symmetric with respect to the x-axis. And then the y-axis, we're going to replace x by -x, because y is equal to -x to the third is not equivalent to the original, and the graph is not symmetric with respect to the y-axis. The origin, we're going to replace x by -x and y by -y. Now, because this equation is equivalent to the original, multiplying both sides by -1, the graph is in fact symmetric with respect to the origin. So now we're going to go ahead and create a table of values. Now, because of the symmetry, we need to locate only points on the graph for which x is greater than or equal to 0. And so, because 1, -1 is on the graph, and the graph is symmetric with respect to the origin, then the point -1, 1 is also on the graph. Here's another example. We have the equation x is equal to y squared. We're going to graph x is equal to y squared. We're going to find any intercepts, check for symmetry. So we're going to graph x is equal to y squared when y is greater than or equal to 0. So the lone intercept again is 0, 0. The graph is symmetric with respect to the x-axis. And then do you see it makes sense, because if you think about y is equal to x squared, you know it's a parabola that opens upward. Now, if we get x is equal to y squared, it's still a parabola, but it actually opens to the right. So it will be symmetric, whereas an original the key parabola, y is equal to x squared, is symmetric with the y-axis. This one is symmetric with the x-axis. Then we're going to, here, the next one, we're going to graph y is equal to 1 over x. And so we're going to find any intercepts and check for symmetry. So check for intercepts. If we let x equal to 0, we obtain 0 in the denominator, which makes y undefined. So we conclude that there is no y-intercept. If we let y is equal to 0, we get the equation that 1 over x is equal to 0, which has no solution. So we conclude that there is no x-intercept. So the graph of y is equal to 1 over x does not cross or touch either of the axes. So next we're going to check for symmetry. We're going to replace y with negative y. And so here you see which is not equivalent to the original. For the y-axis, we're going to replace x with negative x. This again is not equivalent to the original. And the origin, we're going to replace x with negative x and y with negative y, which yields negative y is equal to negative 1 over x, which is in fact equivalent to the original, so the graph is symmetric with respect to the origin. Now, you're going to set up a table. We're going to find some values. And this is the graph of the y is equal to 1 over x. And that's the end of 2.2. Thank you.